As December reaches its midpoint, something extraordinary happens in the sky. But why do people all around the world turn their heads to the sky on the same night every year? Why does the sky suddenly fill with streaks of light on certain nights? And, most importantly, where do these lights come from? Why do they appear in different colors? And why do some explode like fireballs? The answers to these questions are hidden in the cosmic journey that Earth makes on the night of December 1314, because at that very moment, our planet passes through the invisible debris stream left behind by 3200 Phaethon. This river temporarily transforms the sky into a stage of light. As Earth approaches, astronomers ask the same question again. How generous will the sky be this year? Behind this curiosity lies a natural phenomenon that repeats every year, yet looks different each time: the Geminid Meteor shower. Although many people see this event as a show, there's another question. Is it dangerous for Earth? No. The particles that create the Geminid shower are mostly no bigger than grains of sand and burn up completely when entering the atmosphere. Therefore, there's no need to worry about large fragments reaching the surface. The Geminid meteor shower is known as one of the brightest and most intense natural events of December. During these dates, people across the world witness the same trails of light as they look up at the sky. Sometimes brief streaks appear, sometimes blue, yellow, and red sparkles follow one after another, all spawned from the remains of Phaethon. Phaethon has a different source than most meteor showers. The Geminid shower does not originate from a comet, but from an asteroid, making it unique. When passing near the Sun, its surface overheats, cracks, and tiny dust particles are ejected into space. Thus, a debris stream is formed, plunging Earth into it each December. At this point, another common question arises: why do meteors have different colors? This is because of the chemical composition of the particle and the heat it reaches in the atmosphere. Sodium produces yellow, magnesium creates green, calcium forms purple, iron, bright yellow-white, oxygen and nitrogen ions result in shades of blue. That's why Geminids tend to appear more colorful than most other showers. Another interesting aspect of Geminids is that Phaethon itself is a celestial body not yet fully understood. It looks like an asteroid, but some of its behaviors are comet-like. Therefore, in the scientific world, it is known as an odd object. On the night of December 1314, people across many continents watch the same scene in the sky. The prairies of North America, the cold fields of Europe, the snow-covered mountains of Asia, and the warm deserts of Africa all shine with the same light trails. This cosmic event, quite astonishingly, can be seen even from the horizon in bustling metropolises. Geminid meteors streak across the sky at rates of 100-150 per hour. Although they can be seen all over the sky, the streaks seem to radiate from near the Gemini constellation when viewed from afar. And people wonder, do these particles burn up completely in the atmosphere? Yes, almost all are millimeter-sized and evaporate completely in the atmosphere. Finding a Geminid fragment big enough to reach the ground is nearly impossible. These particles enter the atmosphere at a speed of 35 kilometers per second, rub against air molecules, turn into plasma, and we see them as trails of light. Some meteors explode more brightly at this stage. The fireball phenomenon is because the particle is larger or burns longer. These trails of light are much more than a fleeting sparkle. Each represents a fragment from the deep past of the solar system. Some have wandered space for thousands of years, while others are relatively newly lost from Phaethon's surface. This show is not just a visual spectacle, it is also a valuable opportunity for science. Observatories measure the speed, brightness, and entry angles of the meteors. These data allow a better understanding of Phaethon's structure. Observations by radio waves even allow tracking meteors in cloudy regions. At this time, another question often arises: do meteor showers pose a risk to spacecraft? Yes, but most of the time, it's minimal. Spacecraft can encounter high-speed particles just micrometers in size. For this reason, organizations take protective measures, such as orienting spacecraft in certain directions during intense meteor streams. Throughout the night of December 13-14, the world unites under the same sky. In deserts, mountains, beaches, and snowy plains, people look up and witness the same natural event. Some regions may be cloudy, but people know that above the clouds, the atmosphere is still filled with streaks of light. Toward morning, the meteors diminish. Earth slowly leaves Phaethon's debris stream behind. And not only the trails of light remain, but also a shared experience. One last frequently asked question should be addressed: does this event change the atmosphere? No, meteor showers are too small in scale to affect the atmosphere. The substances produced by burning are released in such minuscule amounts that they cannot change the composition of the air. And it is known that the Geminid shower will return again the next year. As Earth passes through Phaethon's trail, the sky continues to shine every December. If you enjoyed the content, don't forget to like, subscribe to the channel for new content, and write your thoughts about meteor showers in the comments below. Did you have a chance to watch the Geminid meteors in your region? See you in the comments.